Good morning, children. Welcome back to our physics class, heat lesson. Okay, let's continue the lesson, heat. Last class, what did we learn in heat lesson up to now? Let's quickly recollect it. We have learned what is meant by hot and cold, right? How to measure temperature. What is meant by temperature, how to measure temperature, that is the device which is used to measure temperature, which is called as thermometer. In that we have learned about different types of thermometers. What are those different types of thermometers? We have learned about the clinical thermometer, which is used to measure human body temperature. Okay, in that we have again seen two more different types of thermometers. One is mercury thermometer, digital thermometer, which does not make use of mercury, and the third one is infrared thermometer. Okay, and we have learned about laboratory thermometer. We have learned about even the other class, I think I showed you laboratory thermometer and also maximum minimum thermometers also I have showed you. Okay, so you have seen all the three different types of thermometer. You have learned the differences between a clinical thermometer, laboratory thermometer. You have learned what are the precautions that need to be taken while using a clinical thermometer. What precautions you need to take while using a laboratory thermometer. Isn't it? Do you remember all that? Good. So we have even learned what are the precautions. Why mercury is chosen as a liquid in thermometer. Why not other liquid? Why mercury is preferred. All this we have learned up to now. Isn't it? So today, in today's class, we are going to learn about transfer of heat. What is meant by heat transfer? How does transfer of heat takes place? Okay, so that we are going to learn it. You know what is meant by transfer, right? So how does this heat transfer takes place? What is heat transfer? Right. Before starting this class, before starting making my arrangement for this recording, I have boiled this pan. I have put it on the stove. This pan. Okay. This pan I have put it on my stove. So this was very hot. I could not touch it at that time. But then it has taken some time for me to make all this arrangement, and now I could easily touch it. It's still warm, but then I can still touch it. Okay. So what happened to the temperature of it? What happened to it? It was very hot at that time, but what happened to its temperature now? Okay. What happened to its temperature? So it has lost its temperature to the surrounding environment. Okay, the temperature of this hot pan is lost to the surrounding environment, which means that transfer of heat has taken place. From where does it take place? It has taken place from a hot object to a cold object. So transfer of heat always takes place from hot end to or hot object to cold object. Suppose if I have both the objects with the same temperature, can transfer of heat take place? No. Unless there is a difference between the two temperatures, heat transfer cannot take place. Okay. So two conditions for heat transfer. The first condition for heat transfer is transfer of heat takes place only from hot object to cold object. Okay. And if heat transfer has to take place, there should be a difference between temperature between the both. Only then transfer of heat takes place. If the temperature of both the objects is same, then no transfer of heat takes place among them. Okay. Transfer of heat can take place only if there is a difference between the temperature of two objects. Okay. And transfer of heat always takes place from hot object to cold object. Okay. These are the two things that are important. Right. Now, let me tell about, I'll tell you one small activity. Okay. You have already learned this lesson, but then this is only a revision. Okay. You have learned that there are three different types of heat transfer. One is conduction, and then convection and radiation. Okay. Do all objects allow heat to pass through them? conduct heat to pass through them? I don't think so. All of them do not allow. There are certain substances which allow heat to pass through them, and they are called as conductors. Some substances will not allow heat to pass through them. Okay, they are called as insulators. In our day-to-day life, we make use of both the type of materials, both conductors and insulators we need. Okay, substances which allow heat to pass through them, materials like metals like copper, steel, aluminium, zinc, all these which allow heat to pass through them, they are all called as good conductors of heat. Okay, they are all good conductors of heat. Plastic, wood, melamine, all these are the substances which do not allow heat to pass through them. So they are called as insulators or bad conductors, or otherwise they are called as insulators. So we have learned one new terms today, two new terms in fact. What are conductors and what are insulators? We have learned two things up to now. One, what are the conditions necessary for heat transfer to take place? Okay, there are two conditions that are required. The first condition is that, what is the first condition? Yes, the difference between the temperature of both the objects should be different. Okay, if transfer of heat has to take place, the temperature of two objects have to be different. Okay, that is one thing. Then transfer of heat always takes place from hot object to cold object. That is the second thing. Okay, two conditions. And we have learned about two more definitions, that is, what is meant by conductor and what is an insulator. Conductors are those which allow, they are the materials, mostly they are metals, which allow heat to pass through them. They are called as conductors. Insulators are those which do not allow heat to pass through them. Okay. For example, in our day-to-day life, we make use of both conductors and insulators. This is copper. This is a good conductor of heat because heat has to conduct. This has to be a good conductor because I want the things to get cooked in this. Okay. This is an insulator. This is bakelite. I can hold it. Suppose if this is also made up of metal, can I hold it? No, maybe I should use a cloth or tongs. Otherwise, this will, my hand will get burnt, isn't it? Now, without any cloth, I can hold it. Even when it is on the stove, when this whole pot, when it is curry is getting cooked in this, still I can hold it, isn't it? So, in our day-to-day life, we make use of both conductors and insulators. This is a conductor of heat. This is an insulator. In the same way, here for the cooker also, this is an aluminium one. This is a conductor of heat. This is an insulator. Okay. The milk boiler. These are all conductors in our day-to-day life. When you get into your kitchen, you can see so many things that are conductors and insulators. All these are, this is a conductor, steel, which is a conductor, and I can still hold when the milk is boiling in this because this is an insulator, bakelite, which is a insulator. Okay, this is even an iron box. I can, when it is, this is a conductor of heat. I can hold it. This part I cannot touch it. If I touch, my hand will get burned, isn't it? But then, when it is hot, when it is now I can touch. But then when the switch is on, when it is getting hot, when I am about to iron it, I cannot touch. This part will be very hot. But then still I can hold it here because this is a bad conductor of heat. This is an insulator. Okay. So, wood, this is a conductor. This is a conductor of heat, and then this is, I can hold here because this is an insulator. This is an insulator. Okay, wood, which is an insulator. So in our day-to-day life, we make use of both conductors and insulators. We need both of them. Now I think it's clear what is meant by conductor and what is an insulator. Conductors are materials that will allow heat to pass through them. Insulators are those materials which will not allow heat to pass through them. Okay?